Hello students. So the next part is about projections and least squares. So here you are going to find out if there are a simultaneous equation which cannot be solved. If we have no solution, then but then also if you want a solution, what to do? Now, like if I say you have an equation x equals to 1 and another is 2x equals to 1. The value of x exists here? No, we cannot have a solution here. But in that case, if we need to solve it, these equations are from one a single system we are operating like a motor or any system that we are operating, and we are from that if we have observed and got these equations and we want a solution, then like one is temperature, one is humidity, any manner. So any system, if it's mechanical or electrical system, if you have equations, if you have got equations from the observation and you want to solve that, then the values of x cannot be determined here. So we say that we don't have any solution. But here in the Gaussian, that is using Gaussian method, that is row reduced echelon form or the echelon form, we don't get the solution. So in one of the possibilities, either I take x equals to 1 or x equals to 1 by 2. But if I take x equals to 1 or x equals to 1 by 2, it may satisfy some of the equations, other equations, and it may not satisfy the some of different equations. So hence, what is the solution for that? What we have to do? So what we can do is that we have to find the values nearer to the x. Here x is 1 and x is 1 by 2, as I told you in the previous example. Try to get x very nearer to that so that it can satisfy both the equations nearer. The error, that is the original value of x and the projected value or the estimated value of x, should be, the difference between them should be very negligible. So we call that as a least square method. We have a least square method, so through which we can find out the nearest values of b. As in, I told you, the coefficients of the equations are represented in matrix. So each column represents one of the variables. So you can say the column space should be equal to the when you are finding out determining x, that we should be nearer to the values of b. So so when we are solving those type of equation, we cannot expect that we will not have a we will not have a exact solution. So we can have certain amount of error when we are choosing x. So to minimize that, we have to minimize that error, which can give you a better solution for x. So average error should be equals to be almost equals to 0, approximately nearer to 0. So that is, you are having the values of b, instead of lying on a straight line, they deviate here, and instead of this point they may deviate here, and there are this difference between the 2 points, the actual values of b and this is the expected value, and this is what we have got. The difference should be very less. So this has to be minimized. So the topic least squares and the projections. So consider here. So here one system is given. Look at this system. The system is 2x equals to b1, 3x equals to b2, and 4x equals to b3. What should be the values of b1, b2, b3? They should be in the ratio of 2, 3, 4. If x equals to 1, b1 should be 2, 3, 4. b1, b2, b3, 2, 3, 4. If x equals to 2, what should be the values of b1, b2, b3? It should be 4, 6, and 8. Then we say the equations are solvable. If they are not in that ratio, the equations are not solvable. So how to solve that? The most convenient method is to convenient average comes from the sum of the averages. So just look at how do you find the errors. So we have the 2x1 minus b1, and from the first equation, squaring the second equation, that is the difference, ax minus b2 whole square and 4x minus b3 whole square. Whatever values we have found for x, if I substitute and square them and add this, whatever I get, that we call it as a e square, and this should, if this is equals to 0, that means the values of x what we have found out are the tallying with your b1, b2, b3. If that is the case, then we will get it 0. Or we try to minimize this e square equals to nearer to the 0, minimum error. So the minimum error is that point. How do you get every time a minimum error? How do you find from the e square? By differentiating the e square and equating it to 0, we can find out the point at which we get a minimum error, or e square becomes 0 if we have an exact solution. So when we have exact solution, you can say e square equals to 0, or you may have nearer values also. So and that is, you just find the point which reduces the average error. So here we can see, here we have differentiated and equated it to 0, and when you do that, you can find what will be the model of x. So here just separate the x terms and also separate the b values. What you will be getting here, 4x, right, 2 square, and see 3 square into 3 into 3, 3 square, and 4 square, 4 and 4 x square. So all this into x square I can see. And what about the b1? You can see 4b1, that is 2b1. Already here you have 2b1, 3b2, and 4b3. So this I'll be getting, and the other 2, 3, and 4 I'll be getting it here itself. So if this 2 I can make it equals to 0, because if it goes this time, only these 2's are remain. So only you have 2b1, 3b2, and 4b3. So equals to, so x equals to, you will be getting like this. So I can call them in terms of matrix, that is a column matrix. What is what is A? These are the coefficients of X. So that is A transpose multiplied with the B values, that is B1, B2, B3, then you will be getting this equation. And how do you get this equation? When I multiply A, column A with the transpose of A with the A, I will be getting, that is automatically it will be the square of the elements. So when we have, this is the solution when we have a single variable. So I showed you the example. So single variable. So this the least square method, the least square method or the solution in one unknown. When you have one unknown and many equations, so that time you can find the prediction or the x estimation of x, which is nearer, which should be nearer to the actual x, will be A transpose B divided by A transpose A. So this will give you the value of x, which is nearer to the original x, which will be nearer to the original x, and you will have the error will be least. And if it is x cap is equals to x, then it automatically means you have a solution for that equation. So here it is nothing but how do you illustrate geometrically this problem. This is nothing but your error vector E is that is error vector E connecting B to P must be perpendicular to A. That is, you have an error vector E. The error vector V is that your actual value of x minus x cap in that equations, if you take, that is your error vector. So you can say that error vector connecting to B, what are the points at B? If this is a line, if the equations are representing it as a line, so this may be your B1, this may be B2, but you will be getting the value somewhere here. So the difference between that will be an error. So it will be, must be perpendicular to A. It should be perpendicular to the values of A. So if I install B, and this will be your you are having values x. So coming to this point, you can see that is orthogonality of A and E. The original vector A, the given vector A, and the E orthogonality, if they should be perpendicular, that automatically mathematically means they should be equals to 0. That is A transpose, that is A transpose, and the error is what? Actual values of B, and if you multiply x into A, we should be getting B. So what will be error? B minus the estimated value into A. If XA is